Greatest common factor. What is greatest common factor? The greatest common factor is an important concept in math that will appear again and again in a variety of applications. It is the largest, or greatest, number or term that is a factor of two or more numbers or terms, the common factor. We will begin by defining what a factor is. A factor of a number or term is something that can be multiplied by something else to result in that number or term. For example, to get 4, we could multiply 1 times 4 or 2 times 2. So the factors of 4 are 1, 2, and 4, the numbers that we can multiply to get a result of 4. A given number or term always has at least 2 factors, itself and 1. For example, to get 24, we could multiply 1 times 24, so itself and 1, or we could also multiply 2 times 12, 3 times 8, and 4 times 6. So we could list these numbers to show that the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. Notice that I have listed these numbers from least to greatest, but you don't have to do that. It just makes it easier to look for patterns and to find common factors if we list them consecutively. You can list them as pairs if you want to. If we look at terms that include variables, the number of factors will become even larger. But right now, we're just going to worry about numbers. How do we find the factors of a number? We could identify the factors of a number by listing the pairs of numbers that multiply to equal that number. So we start with the number and 1 as the first pair of factors. Then check to see if the number divides by 2, then 3, and so on. You can stop checking when you get to half of the original number or when you have a matching pair of factors. For example, if we wanted to find the factors of 36, we could start with 1 times 36. Then we check to see if 36 is divisible by 2. How do we know if a number is divisible by 2? If the number is even, we know that it is divisible by 2. We could also use a calculator to check. If you divide a number by something and you get a whole number as an answer, no decimal or fraction part, then that number is a factor. So far, we have found that 1, 36, 2, and 18 are factors of 36. Now check to see if it's divisible by 3. 36 divided by 3 equals 12, so now we know that 3 and 12 are also factors of 36. Next, check to see if 4 is a factor, then 5, then 6. When checking to see if 6 is a factor of 36, we see that 6 times 6 equals 36, so we have a matching pair of factors. Our complete list of factors of 36 is 1, 2, 3, 4, 6, 9, 12, 18, and 36. We identified earlier the factors of 24. 1, 2, 3, 4, 6, 8, 12, and 24. Another form of matching factors is 4 times 6 and 6 times 4. So when we found that 4 times 6 equals 24, and 5 was not a factor of 24, and then the next pair of factors is 6 times 4, which is the same thing as 4 times 6, we knew that we had identified all of the factors. You can stop checking now. So how do we know when we have found all the factors? We can stop looking for factors when we have checked all the numbers up to half the value of our original number, or if we have found a factor that multiplies by itself to result in our number, Or we have found a pair of factors that have no factors of our number in between them, such as the example with 4 times 6 and 6 times 4.